This video looks at the Mplab Icd 5 in-circuit debugger, Microchip's latest fast and feature-rich emulation and programming tool. The Mplab Icd 5 supports all Microchip microcontrollers, including PIC, DSPIC, AVR, SAM and CEC devices, and works with the many varied on-chip debugging interfaces these devices implement. Utilising the built-in emulation circuitry of these target devices, the Icd 5 can execute code with true electrical and timing characteristics, can conditionally halt execution, and can upload program flow and memory data for display in the Mplab Icd. Getting started with the Icd 5 is easy. First, connect the Icd 5 to your host computer using the supplied USB-C cable. The Icd 5 obtains power in ways unlike previous generation Microchip tools. Power can be obtained through the USB connection to the host computer. When using a compliant USB-C connection, 3 amps is available to the tool, with up to 1 amp being made available to power the target. Alternatively, the Icd 5 can obtain power from an Ethernet connection. To use power over Ethernet, connect to an endpoint network switch, or place a midspan device between the Icd and a regular switch. Such a setup can deliver a higher current than possible through USB. Regardless of how you connect the Icd to your host computer, you can always power the target board through an external supply if required. Communication between the host computer and the Icd 5 defaults to USB. If Ethernet is preferred, run the Mplab IDE, ensuring you have installed the latest version. Change the connection type by selecting the Manage Network Tools menu item. For the selected tool, choose Ethernet using DHCP to connect using an Ethernet cable and have IP addresses automatically assigned, or Ethernet static IP to connect using an Ethernet cable with connection settings that have been manually specified. Connecting via Ethernet allows the Icd 5 to be physically separated from the host computer, and also permits it to be used from virtual environments, such as a Docker container used in CI/CD pipelines. Update the connection type with your selection, disconnect the USB cable, and the Icd 5 will reboot using the new network interface. The tool provides an 8-pin RJ45 modular connector, supporting advanced interfaces such as 4-wire JTAG and serial wire debug. Connecting a 6-pin RJ11 cable allows legacy interfaces such as 2-wire JTAG and ICSP to be used. An adapter board included with the tool provides standard connectors for JTAG, SWD, ICSP, and AVR protocols. If connecting to your own hardware design, the interface circuitry must meet the Icd communication specification, as described in the Mplab Icd 5 in-circuit debugger's user's guide. Configure existing projects to use this tool by opening the Project Properties dialog. Click the Configuration category and select Icd 5 from the list of hardware tools. When creating new projects, proceed through the New Project dialog, entering your target device and then select Icd 5 as the tool. Review the debugger's settings in the Project Properties dialog under the Icd 5 category. The default settings typically work with any hardware, but enable the Power Target Circuit from Icd 5 option if your target board is powered via the Icd 5. Leave the option disabled otherwise. Ensure that under the Communications option category, the Target Communication Interface setting is correct for your configuration. The controls to run and debug programs will be familiar to those who have used other Microchip tools. For example, you can simply click the Debug Project button to have your project built, downloaded onto the target board, and then executed. When debugging, breakpoints can be set, program execution paused and stepped, and variables and registers can be monitored or modified in various views. For some SAM devices, trace debugging utilizing the onboard instrumentation trace macrocell is also available. Enable this from the ICD5 category in the Project Properties dialog under Trace and Profiling. See the ICD5 User's Guide for help creating a device INI file. Under the Clock Option category, ensure the clock frequency is correct for your hardware. When running code using Trace, printf-style debugging statements added to your code output UART format data over the serial wire output pin. The results of expressions in these statements are displayed in the ITM display view in the IDE as the program executes. To see supported devices, features available by device and tool, and resources used by the ICD5, select the Release Notes menu item in the Mplab Icd, then click the relevant links for more information. The new Mplab Icd5 is a versatile development tool, capable of production programming as well as debugging Microchip devices at maximum speed through USB and Ethernet interfaces. Providing faster programming times and useful debug information, it will help facilitate development of all your future projects.